Hello. So the stream will be starting at 6:15 EST, so until then, just wait by. The stream will be starting momentarily. Please wait until then. Okay, so without further ado, let's go ahead and get into the stream. So in the stream, I answer your math questions, and if you'd like, just put a math question in the chat. And if you don't have anything, I have some math questions I would like to solve for you guys. Okay. So the first math question I have. Okay, so we have this problem right here today, and it says let k equals 168 times 900 equals 151. So this problem says let k equal. So this problem says let k equal 168 times 900, which is equal to 151,200. And how many positive integer divisors does k have? And this is actually a math counts problem. But without further ado, let's go ahead and get right into the problem. So we have that k is equal to 168 times 900. And we can split these problems up. So 168, if we prime factorize it, it will end up being, we'll have 2 and 84, I believe. Correct me if I'm wrong. And then afterwards, we have 42 and 2, 2 and 21, and 7 and 3. So converting this, we have 2 cubed times 3 times 7. And now let's go to the 900. So 900 is basically just 30 times 30, or 30 squared. And then we converting this, we get 2, 3, and 5, and we have the same for both. So this would just end up being 2 squared times 3 squared times 5 squared. And this is what prime factorization really is. So now let's use these. 2 cubed times 3 times 7 squared, and 2 squared times 3 squared times 5 squared. And let's multiply them together, since that's what this problem is. So let me just erase this really quickly. So we have 2 cubed plus 3 times 7 squared, and 2 squared times 3 squared times 5 squared. Now we can erase these. So now what we can do is 2 cubed times 2 squared is just 2 to the fifth. 3 times 3 squared is just 3 cubed. 5 squared would just be 5 squared, and 7 squared is just 7 squared. So now we have this expression right here. And there's a really cool technique that we can do to solve this, considering we just need to find how many divisors it has. So we can use something called we can use a similar technique to probability to solve this. So 2 to the fifth is just we can convert 2 to the fifth. We can choose like which one, how many twos we want. So we can choose 0 twos. We can choose 1 2. We can choose 2 twos. We can choose 3 twos, 4, and 5. So there are 5 possible combinations for 2 to the fifth. And for 3 cubed, we can convert that into 4 possible combinations. So that's 3 to the 0, 3 to the first, 3 squared, and 3 cubed. So that's 4 possible combinations. And as you can see, there's a pattern going on here. So 2 to the fifth, there's 6, since 5 plus 1 is 6, and that's actually the pattern. 3 plus 3 plus 3 plus 1 is 4. 2 plus 1 is 3, and 2 plus 1 is just 3 again. So if we multiply these together, since we need to find how many 2s there are, how many 3s there are, and we can combine them all together to get an answer. So then we multiply them all together, and it's just 6 times 4 times 3 times 3, which is just 24 times 9, which would just be 240 minus 4, or minus 24. And this would end up just being 216. And that's our answer for this problem. And this problem is actually really simple. It's all you have to do is do that one trick, and that's all for the problem. So if you guys have any questions, please let me know. But if you don't have any more, we'll do another problem. Okay, questions. I'll go ahead and do another problem. Okay, so now let's do this problem right here. So this problem we have right here says, what is the unit digit of 2 to the power of 2017 times 7 to the power of 2017? And this is a huge expression, but for now, let's go ahead and get right into the problem. So first, if you couldn't tell already, this problem was made in 2017, knowing that it has 2 to the power of 2017, and that's just a little Easter egg that math competitions have. But to solve this problem, you wouldn't want to multiply 2 to the power of 2 to the power of 2017, as that's just astronomical. So what we do is we calculate the unit digit of this one, and we calculate the unit digit of this product. I mean this exponent, and then we multiply those two unit digits together to get an answer. So how do we find the unit digit of 2 to the power of 2017? So what we do is we have to find a pattern. So 2 to the power of 1 is just its unit digit is 2. 2 to the power of 2, its unit digit is 4. 2 to the power of 3, its unit digit is 8. 2 to the power of 4, its unit digit is 16. It's 2 to the power of 4 is equal to 16, but its unit digit is 6. And then 2 to the power of 5 is 32, so its last digit would be 2. 2 to the power of 6, its last digit would be 4, as that's 64. 2 to the power of 7, that's 128, so that would just be 8. And 2 to the power of 8 is 256, so that's 6. Now, as you can see, there's a pattern going on here. We start with 2, we go to 4, we go to 8, and then we go to 6. So let's write that pattern down for further reference. Okay, so now let's do 7 to the power of 2017. So 7 to the first is just going to be 7. 7 squared is just going to be 49, which would end in a 9. 7 cubed, you just multiply 7 by that, and then you get a unit digit of 3. Then 7 to the fourth, I'll put that right here, will just be 3 times 7, so we have a unit digit of 1. 7 to the fifth, 7 times 1 is just 7. 7 to the sixth, 7 times 7 is just 9 at the end. And you can see a pattern goes on here as well. So let's write down that pattern. So the pattern in this one is just 7931. So now we have these two patterns right here. So what we want to do is we want to convert this 2017 into something that we can use. Like if we can do like 2 to the power of 5, we know that it has the same unit digit as 2 to the power of 1. Even 2 to the power of 9 has the same unit digit as that. And actually what we can do is we can try like dividing by 4. So because this goes in a pattern of 4, what we can do is we can do 9 divided by 4, and that's just 2 remainder 1. So because that's just 2 remainder 1, and it has a remainder of 1, which is the key thing that we're looking for, it converts from 9 to 1 just like that. And we can use something called modular arithmetic. I'm not sure if you guys are familiar with that, so I won't get into too much. We won't get too much in depth into that. But basically, our trick is if we divide by 4, we can just solve it. So if we do 2 divide, if we so this first term, we get 2 as the unit digit when we divide by 4, and we get a remainder of 1. So let's write that down. we would get a remainder of 4. I mean, we'd get a remainder of 2 when we divide by, when we have like 2 to the power of 10. And that has a unit digit of 4, so we can write 2 up here. And then 8, if we have 2 to the power of 11, and we divide that by 4, we get a remainder of 2. I mean, a remainder of 3 there. So that'd just be 8. I mean, 3 there. And then 6, if we have 2 to the power of 12, that's the same thing as 2 to the power of 4. Even 2 to the power, so it's the same thing as 2 to the power of 4. So we'd have a remainder of 4, but when you think about it, dividing by 4 does not give you a remainder of 4, so we would just have a remainder of 0 there. And using the same logic, it's the same thing for 7, 9, 3, and 1. So 7 would have a remainder of 1. This would, when you get this, it should have a remainder of 2. When you get a remainder of 3, it would be a 3 at the end. And when you get a remainder of 0, it will have a 1. So now using this fact, we can actually solve the problem. So we have 2 to the 2017. So we need to divide 2017 by 4. Now, I'll make a divisibility trick video coming up soon. But for now, let's solve that. So 2 to the 2017 divided by 4. It's the same thing as 17 divided by 4. As when you see 2000 divided by 4, that's just 500. And 17 divided by 4, that gives us 4 remainder 1. And what we really want is this remainder right here. And in this case, that's just 1. So because it's a remainder of 1, as I said before, because it's a remainder of 1, it will have a unit digit of 2. So I'll mark that. And that remainder is really the only thing we need here. So we'll put 2. And we'll put a multiplication sign right there. As what we want really here is we want the unit digit of 2 to the power of 2017 and the unit digit of 7 to the power of 2017. So now let's do 2017, except we already did this. We already did 2017 divided by 4, since this is the same. It's just a pattern of 4 digits. So we get a remainder of 1 again. In this case, the remainder of 1 correlates to the 7 right up here. So we'll put a 7 down here. And now if we just do 2 times 7, we get the answer for our problem. And in that case, 2 times 7 will just be 14, which has a unit digit of 4. And that's our answer for this problem. Some key things to know is, even though 2 times 7 is 14, that 1 will not actually be right, since we're calculating everything for the unit digit, which can be solved using the patterns, but the 1 in front won't be valid. So if you have any questions, please feel free to put them in the chat. Other than that, we'll get on to the next problem. Again, feel free to ask any question. Otherwise, I'll pull out another question and we can solve that. Okay, so let's solve another problem together. So this problem says how many 4-inch square tiles are needed to cover a wall that measures 6 feet by 8 feet. And this is another math cons problem that we have here. So let's look over the problem one more time. So this problem says how many 4-inch square tiles are needed to cover a wall that measures 6 feet by 8 feet. So let's go ahead and get right into the problem. So what we have here is always when you have a geometry problem, what we do is we want to draw it out. And that's usually a common strategy with geometry problems. So we have a 6 feet by 8 feet wall, and we have 4-inch square tiles. So we have 6 feet. We'll put 6 feet right here. And we'll put 8 feet right here. And we have 4-inch square tiles. So that will be just like this small. And another thing to consider is this says 4-inch. I almost made a mistake where I thought it was 4 feet. So be careful with that. So we'll put like 4-inch on both sides. And that's our square tile there. So now we need how many are those to cover the whole wall. And in this case, what we do with the wall is we want to convert 4 inches to feet. So in case you didn't know, 12 inches is 1 feet, 1 foot. And if we divide both sides by 3, we end up getting a third of a foot is equal to 4 inches. And that's really what we need in this problem. So now that we have 6 feet on the left side, and it's 4 inches tall, which is also 1/3 of a foot tall, we do 6 divided by 1/3 to find how many squares can fit vertically. And to find out how many squares can fit horizontally, we do 8 divided by 1/3 to get how many, since we need to find how many is needed horizontally. And if we lay 3 here, we get 1 foot of distance. So just evaluating these, how do we do a fraction inside a fraction? And in this case, how we do a fraction inside a fraction by multiplying by the reciprocal. So if we put something in the denominator, it's the same as multiplying by the reciprocal. So 6 over 1/3, 1/3's reciprocal is just 3. So that's just 6 times 3. So that's 18 there. And 8 over 1/3, that's just 8 times 3. And that's just 24. So now we have uh, these two squares, 18 that can fit vertically and 24 that can fit horizontally. And now we need to find a way to evaluate this quickly. So this is the same thing if you use difference of squares, which I'll get into another video. It's the same thing as 21 squared minus 9. And 21 squared is just 441. So that's just 441 minus 9, which in this case, that would just be 432. And that's our answer for this problem. So using a simple trick, we can just solve this problem as quick as possible. And if you have any questions on how to solve geometry problems, please feel free to ask in the chat. But we'll do one more problem for the night and then I'll call it a night. So if you have any questions, just ask. I'm happy with answering your questions. Okay, so it doesn't look like anyone has any questions or problems. So I'll go ahead and solve the last problem for the night. So the coming question is actually a probability question. And it's actually a really unique probability question that I really liked. Since there's a really slow way to solve it, and there's also the fastest way that you can solve it. And usually with probability questions, they're kind of like situational and you don't really know how to solve it. So it says, suppose Luke spins the pointer on a fair 3-color spinner. What is the probability that the pointer lands on the same color twice? So like I said, this question states that suppose Luke spins the pointer on a fair 3-color spinner. What is the probability that the pointer lands on the same color twice? And this, like all my problems, are math count or is a math counts problem. But let's go ahead and get right into the problem. So with this probability question, it is important to note that it says fair right up here. And that means it is like perfectly fair. No like unfairness going on where it just always goes on one color, which is actually possible in some cases. Like if you tilt the spinner down, it can just go on one side. But we have what is the probability that the pointer lands on the same color twice? To do plain old probability stuff, uh, let's construct a spinner, since that will actually make the problem look cooler. So we have rad red, we have the green, the gorgeous green, and then what's an adjective we can use for blue? We have the belated blue. And the spinner lands on one of those colors every single time. And by the way, this is not drawn to scale. I'm pretty sure this is probably the worst spinner anyone's ever drawn. Since that green looks like it has a lot of very little space. So that's the spinner. And the question asks what's the probability that it lands on the same color twice? So if we use plain old probability, it lands on, let's make it into cases. So we have red, blue, and green. And this is the solution without the trick, as the trick is really fast and you don't even need these colors. So it lands on red 1/3 of the time the first time, since it's fair and there's 3 colors. And it lands 1/3 of the time the second time. So we can do the same thing with blue. 1/3 times 1/3, and green 1/3 times 1/3. So 1/3 times 1/3 is just 1/9. And in this case, we have 1/9 right here and 1/9 right here. So that's just 3 times 1/9. And in that case, that is just 3/9 or 1/3. And that's our answer for this problem. So this problem may seem really simple, but there's actually a much faster way to solve this problem. So let's go ahead and get right into that. Okay, so now we have to find the probability that it lands on the same color twice. Same problem as before, but we don't need the spinner this time. What we can do is, if we think about it logically, what we really have to do is we just have to think of a color, a random color. Let's say we want the first one can land on any combination. So the first one can be red, blue, green. We don't care. The second one just has to match that first one. So if the first is red, blue, or green, the second one just has to be it specifically again. So the first one can be anything, like I established. And because the first one can be anything, the probability that it lands on one of those colors is just going to be 1, since it can be virtually anything, any of these colors. Now the second one has to be one of these colors, the specific color. So if it would be red, it has to be a 1/3 probability. If it's blue, it has to have a 1/3 probability. And if it's green, it also has to have a 1/3 probability. So the second one has a 1/3 probability of matching the first one. And if we multiply this, we just get 1/3. And that's all for the problem. Really, it's a really simple trick. You can solve it in seconds just using this simple trick. That's all for this problem. And that's actually all for this live stream, unless you guys have any other questions. So thank you for tuning in. Leave, please be sure to subscribe down below and leave a like on your way out. And use the chat and mention what other problems you'd like me to solve, or if you'd like me to do any other live streams in the future. So I'll be here for a couple minutes until, if you guys have any questions. But really, that's all for the stream. So thanks for tuning in. Thank you for the 4 of you that stuck around. Okay. Thank you for the 4 of you that stuck around. But that's all for this stream, and I'll see you in the next video/stream. Until then, stay crazy.